Okay, now we are getting started with second semester stuff. Finally. This stuff is where it definitely gets harder, especially at like the very end where we learned the last part. I'm actually gonna, uh, yeah, whatever. So yeah, let's get started. So now we're on logs. And so basically it gets simple. It starts off simple, but it will get a little harder. But nothing too overwhelming. Okay, so identify if the data modeled in the tables below follow a linear model, exponential model, or neither. Then find the equation that describes the data. By the way, I'm sorry if I sound a little congested. I have strep. I don't know. Deal with it, I guess. All right. So a linear model, exponential model, or neither. So basically, a linear model is when you look at this y thing. You see how they're minus how like each thing goes down by two, so it's like minus two, minus two, minus two. Uh, the thing like four minus two is two, two minus two is zero, and so on and so forth. That explains a linear model. Also, if it was addition, if it was four plus two is six, and then the next one was eight, 10, so on and so forth. But an exponential model is when the model it multiplies or divides. So you see here, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Basically, also meaning 2 to the 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 16. Uh, um, yeah, 2 to the power of 4 is 16, whatever. And that's an exponent. So that's why it's called exponential model. So I'm just going to write exp because it's easier. And then here, it's dividing by 3. So 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 1 is 3 divided by 3 is 1. 1 divided by 3 is 1 over 3, like a third, so on and so forth. So that's also exponential model. Okay, solve the following exponential equations. So now here's where it gets annoying because so basically what you want to do is you want to get the bottom numbers, these ones like 3 and 27, to have the same numbers. We can just forget about them. So the way we can do that is 3, have this one not change, but we can have 3 to the third because 3 to the third is 27. You can do that also on your. Oh, right, I forgot about that. Okay, I'm gonna solve this number 2, and then I'm gonna put a calculator on my iPad, or I don't know, something that you can see. If I can't, then whatever. But yeah, so after number 2, I'm gonna get a calculator thing. All right, so 3 to the third is 27, and then you just do uh, that x minus 3. So now we can just get rid of these 3. And because we have a power of 3 here that is just sitting there, so now we can multiply this 3 to the original exponent. So 3x minus 9. So now we have, since we're forgetting about these ones, we don't like them, should build a wall around them. Quote President Trump. So now we can solve that. So now we just do a normal whatever. So let's do yeah. So let's get rid of this x over here. So we're going to do minus x on both sides. So now we have 1 equals 2x minus 9. Then we're going to put the 9 on the other side. So plus 9 on both sides. We got 10 equals 2x. And now we're going to divide by 2 on both sides, just like normal simplification. 5 equals x. And that is the answer. Great. Now I'm going to do this one. This one is a little tricky because now we have a fraction. So basically, let's go 8x 1 over 2. Okay, so what we want to do now is make this so now we want to, since not 1 over 2 is not going to become 8, right? That's just not going to happen. So what we're going to do is we're going to make these, and 8 will not become 1 over 2, which is, that's just also just too complicated, whatever. So what we can do is meet in the middle somewhere. So we can put this 8 into 2. 2 to the third is 8. We're going to keep that little x there because we're not forgetting about that. And then 1 over 2, 2 to the power of negative 1 equals 1 over 2. When anything is to the power of negative 1, so let's say 3 to the negative 1, it means 1 over that number. So we're going to do 2 to the negative 1. So sort of like extracting it or putting it back, and then 3. So now let's multiply the outside by the exponent. So 2, 3x equals 2, negative 3. And now we can get rid of these because we don't need them anymore. They're the same number now. So 3x equals negative 3. 3, now we're going to get rid of this 3, so we're going to divide both sides by 3. X equals negative 1. And there's your answer. Okay. 25x squared equals 1 over 5x minus 6. Let me clear this up a bit. Thank God this is a video, so you don't have to worry about erasing anything in case you're copying anything down. Okay. So now here also, we're going to meet in the middle somewhere. So we're going to meet in the middle. The first thing that comes to mind, because this is a 5 on the bottom, easiest thing would just be converting it to a 5. Now, the way you can extract the 25 into 5 is 5 squared is 25, right? So 5 squared, and we're going to put the x squared, and then 5 to the power of negative 1 is 1 over 5. So we're not really doing anything. X minus 6. And then we're going to multiply the outside exponents by the inside ones. So 2x squared equals negative x plus 6. Because we can now forget about them also. And now we have this annoying problem. It's long. I don't like it. So now I'm going to actually delete this part so I have more space. It's going to get big. So now we're going to have this one. What you do in this sort of problem is you're going to make it equal to 0. So we're going to bring both of these on over to the other side. So 2x squared plus x on both sides. So plus x minus 6 equals 0. And now we're just going to do that problem. So now, you see how we have a 2 on the side of this x? We don't like that for simplifying or whatever you want to call it, grouping this part. So we're going to multiply that by negative 6 over here. We're going to multiply that by the c, right? Ax squared plus bx plus c. So a times c is negative 12. So we have negative 12, and so we want to multiply it to negative 12. Multiply it to negative 12, and we want to add to 1. So what does that? 4 and negative 3, right? Because 4 minus 3 is 1, and 4 times negative 3 is negative 12. So now we're not gonna get rid of this 2 here. We're gonna still keep that, but that's just how we found out how to sort of split the middle, get it all good and grouped. So we have 2x squared plus 4x minus 3x minus 6 equals 0. And now we can group it. So basically meaning we're going to group each thing by over here in its own little thing. So let's start off with this part. So we can take the 2x outside and have x plus 2, right? And then we never, by the way, this is one thing that stopped me at some point, but I learned somewhere, maybe it's Mrs. Newborn, I'm not sure, but you always have to take, you can't have, the x being negative is not good. like an x like over here. After you group it, can't be a negative. It just won't work well. So take the negative 3 out. It's like even if it was, let's say, a positive number, which will happen, I think, in the next question, we're gonna sort of change it. Like you'll see. So we can take the negative 3x outside and leave 1 plus 2. 1 plus x plus 2. Wait, what? Oh, right. We can't take the negative 3x outside. Take the negative 3x plus 2 equals 0. So now we're going to take the outside numbers and put them in its own little group. 2x minus 3. I'm going to take these ones, see how they match up. That's how you know you did it right. X plus 2 and x plus 2. That gives you confirmation. And now you can have x equals 3 over 2 because, again, you can't have 2x equals 3. It wouldn't work. So we're going to take the 2 and divide it by both sides. Get 3 over 2. And whenever it's a negative, that means x equals a positive number. And vice versa also. If it's a positive, if you get a positive number like c plus 2, it means it's a negative number. So x equals negative 2. And those are your two answers. Okay, great. Now on to this one. 3x squared. 3x minus, is that an 8? Yeah. Minus 8. Okay. 3x equals, okay, so now we want to find, again, a common thing. Now we don't have to meet in the middle here because if you do some math with your calculator, you can tell that 81 to square root of 4, like the 4 root, whatever you want to call this thing, but 4 equals 3. So 3 to the power 4 equals 81. So we're going to keep the 3. We're not going to change anything about it because it's already perfect the way it is. But 3 to the power of 4 is 81. And 3x minus 8. And so now we can multiply the outside. Okay, so with the 4, so 4 times 3x is 12x minus 32. And x squared, because again, we can get rid of these 3 because they're the same number. And now we're again stuck with the annoying equals 0 thing. So now we just get rid of these things on this side over here. So x squared minus 12x plus 32 equals 0. Because again, we're minus on both sides and adding on both sides because we want to get rid of that. This is a 2, by the way. Okay. And now we have that. And now we can just simplify it down. I'm pretty sure this is where I ran into that problem where we have to put the negative on the outside, even if it doesn't really work so well. Doesn't look like it would work so well. So now we have x squared plus minus 12x plus 32. Then we're gonna have x. Since we don't have to multiply the outside by anything because there's nothing over here. So we don't have to do that extra step. But we do still have to find something that adds to negative 12, multiplies to let's say positive 32. No, yeah, and multiplies to 32. So that is negative 8 and negative 4. So x minus 8, x minus 4. Because again, negative 8 minus 4 is negative 12, and negative 8 times negative 4 is 32. Wait, so I'm not sure where I ran into that problem. If we come across it, then I'll let you know. So now x equals 8, because remember, it's the opposite sign, and x equals 4. And those are your two answers. There you go. Okay, now I'm going to see if I can get a calculator on this.